Okay, this is a quick review of motion graphs from back in Unit 1. And I realize this graph is missing labels. I don't know how that happened, but this should be a position in meters versus time graph. Okay, so I'll make sure to tell everybody that. Okay, so what's the state of motion from 0 to 2 seconds? Okay, so from 0 to 2, we've got a slope here. It is a constant slope, so our change in position over our change in time gives us the slope, and that also gives us our velocity. So this is a constant velocity in this first section, okay? Then from 2 to 7 seconds, we have a flat line. Our position is not changing, okay? Our object is staying in the same place as time goes on. That means it's at rest. Now, this is a velocity versus time graph, okay? So this graph, when we have a slope, that means we have acceleration. Remember, acceleration is a change in velocity. My velocity is changing here as time goes on. It's not the same value, okay? It's also changing here, not the same value. So in the first section, I'm accelerating, and in the third section, I'm accelerating. And truthfully, what's happening is I am slowing down in a negative direction here, and then I'm speeding up in a positive direction here. But I didn't ask that, but I'm just throwing that in. In this middle part, I'm on 0. So if I have a 0 velocity, I'm not moving. That means I'm at rest. So this is an object that slowed down, came to a stop for a bit, and then it accelerated, sped back up. Okay. If you have a slope on a velocity versus time graph, that means you have acceleration. That means that the velocity is not staying the same value. It's changing. And the slope tells us the change in velocity over time. Draw a velocity versus time graph for an object that is at rest, not moving. Okay, so that would look like, that would just be along 0. Okay, because I'm not moving. My meters per second would be 0 and would be staying at 0. The slope of a position versus time graph is velocity. So I just talked about that a few minutes ago. That's my change in position divided by my change in time. We calculate slope by getting the rise over the run. Okay, and in the case of this type of graph, my rise is my change in position. My run is my change in time. Okay, that's how we get velocity. And then likewise, again, I'm just throwing this in here, when we have velocity versus time, our rise is our change in velocity, our run is our change in time, and that gives me acceleration. For the graph below, where does the object change direction? So this is it's hard for y'all to see that on the video, but this is a velocity versus time graph. And remember, the x-axis is like a barrier between a positive and a negative direction. These values are positive. That means I'm moving in a positive direction. These values are negative. That means I'm moving in a negative direction. It doesn't mean negative numbers. It means I'm moving in a, one way versus the other way. So in the case of this graph, at 4 seconds, that's where I cross over the x-axis. This is where I'm traveling in a positive direction, and then I change directions here and move into a negative direction. So wherever you cross the x-axis, that means you have a change in direction. Okay, that is one review worksheet.